Hello everybody and welcome to sections 3.1 through 3.2. So your homework today is going to be from both sections and we're looking at the application of derivatives. One thing I would remember is as we go through this, your problems, 3.1 deals with our power rule. So we're going to be working on finding derivatives, so you have to use the power rule. And then 3.2 is your product and quotient rule. So you may have to take derivatives using product and quotient rule as well. But we're going to be looking at the application of derivatives. And just a reminder, derivatives, what is it? It is the slope of the tangent line. Okay. So we're going to be looking at how those apply to different situations. So tangent and perpendicular or normal lines. Just a little bit of terminology here. Normal lines, some textbooks also call it an orthogonal line, but normal lines is a line that is perpendicular to the tangent line at a point on the curve. Okay, so if you see here, here's your tangent line in red, and then the one in yellow is the normal line. It's perpendicular, so they're meeting at a 90-degree angle. One thing that I just want to remind you is that perpendicular slopes, the way you find that is you do opposite, reciprocal. Okay, so if I told you the slope of this tangent line was, let's say, 2, in order to find the perpendicular slope, you do opposite. So now it's positive, so the opposite would make it negative, and then the reciprocal is where you flip it. So it's 2 over 1, so it become 1 over 2. Okay. And then the other thing that we should probably just talk about, since we are talking about perpendicular lines, is just remember parallel lines. Okay, if I have a parallel lines, the slope of parallel lines means they have the same slope. Okay. So let's go ahead and look at an example. So find the equations of the tangent and normal line to the curve y equals x square root of x at the point 1, 1. Okay, so we could find the slope of this tangent line using the product rule because they're being multiplied. However, I can actually just simplify this. So I'm going to start off by simplifying. It's x times x to the 1/2. And then remember, you guys, when you multiply, we add exponents. So this is 1 plus 1/2. We don't write exponents as mixed numbers. We write them as improper fractions. So it'd be x to the 1 plus 1/2 is 3 halves. So 3 over 2. Okay, so that's really the equation that we're looking at. So what I'm going to do is find the slope of my tangent line, okay, which is my derivative. So that's my slope of my tangent line. So I'm going to take the derivative and I'm going to use the power rule. So my original function is y, so maybe I should use y prime. So y prime is equal to, taking my derivative, bring down the 3 over 2, x to the 3 halves minus 1 would give me 1/2. Okay, so there is the slope of my tangent line, and this is my slope of my tangent line at any point. Okay, slope at any point. Okay. I want to go ahead and I want to find the slope specifically at the point 1, 1. So my slope at 1, 1. What I would do is plug in the specific x value that I want to find. So I would take y prime and plug in 1. Okay, so this is 3 over 2, and then it's 1 to the 1/2. So I would just remind you guys that 1 to the 1/2 is really the square root of 1, and the square root of 1 is 1. So my slope of my tangent line is 3 over 2. Okay, it doesn't just ask me for the slope of my tangent line, it asks for the equation of the tangent line. So in order to write the equation, I have my slope, and then I need my point, which they gave us. It's 1, 1. So then I would do point slope. So y minus 1 equals my slope, x minus 1. And I would distribute. So I'd have 3 over 2x minus 3 over 2. And then I would go ahead and add 1 to the other side. So I have 3 over 2x plus 1. So I'd have minus 1/2. Okay. So this is, oops, I forgot my x. This is the equation of my tangent line. So I've taken care of that part. I always make sure I answer all my questions. Then it wants the normal line. Okay, in order to do my normal line, I would need to find my perpendicular slope. to do my normal line. So my perpendicular slope, my current slope of my tangent line is 3/2. So perpendicular would be opposite, so negative, and then 2/3. Okay, so go ahead and flip it. And then we have our point. Our point stays the same, 1, 1. And then I would repeat the same process with point slope form. So it would be y minus 1 equals negative 2/3, x minus 1. So I distribute my negative 2/3. So I'd have plus 2/3. And then I would go ahead and add 1 to her side. So if I add 1 here, that's really 3/3, so I'd have plus 5/3. And once again, you could do that on your calculator and do math frac. And so then right here, this is the equation of my normal line. And your normal line is perpendicular to that line. So that is example 1.